Ever wondered where art, mathematics, and nature intersect? The answer lies in the fascinating world of fractals.
Welcome to a world where curiosity knows no bounds and the extraordinary is just a click away.
Are intricate patterns infinitely repeating themselves in a loop hidden in plain sight. They're in the spirals of a pine cone, the swirls of a galaxy, and even the strokes of a painter's brush. From the grandeur of cosmic structures to the minute details of our daily lives, fractals are the unsung heroes. So buckle up as we embark on this exciting journey to unravel the mysteries of fractals. You may ask, what exactly are fractals? Well, in the simplest terms, fractals are mathematical sets that exhibit a repeating pattern that displays at every scale. This means that no matter how much you zoom in or out, the pattern remains the same. But don't be fooled by their simplicity. Fractals are also known for their infinite complexity. Born from simple equations, these patterns evolve and grow, spiraling outward in an unending dance of shapes and colors. They are the epitome of organized chaos, a perfect blend of predictability and surprise. Fractals are everywhere, from the spirals of a galaxy to the veins in a leaf, and even in the rhythm of our hearts. They are the hidden language of the universe, the mathematical poetry that sings the song of existence. In simpler words, a fractal is a never-ending pattern, a mathematical wonder that continues to captivate and inspire us with its mesmerizing beauty. The beauty of fractals comes from their complex mathematical roots. Now, let's dive into the fascinating world of these mathematical principles. The cornerstone of fractals is a concept known as recursion, a process of repeating items in a self-similar way. Imagine a Russian nesting doll. Open one doll and you'll find a smaller version of the same doll inside. Keep opening dolls, and you'll continue to find smaller and smaller versions, each mirroring the original. This is recursion at work. In mathematics, recursion is depicted through equations or functions that feed into themselves, creating an endless loop. This endless loop, when visualized, takes the form of a fractal. The most famous of these is perhaps the Mandelbrot set, named after the brilliant mathematician Mandelbrot. Another essential principle behind fractals is iteration, the act of repeating a process with the aim of approaching a desired result. Each iteration brings us closer and closer to the fractal's final form, much like a sculptor chipping away at a block of marble until a statue emerges. So how does this translate into the fractals we see? Well, fractals are created by taking a simple shape and repeating it infinitely, with each repetition being a smaller scale version of the original shape. This process of iteration and recursion continues ad infinitum, creating intricate and infinitely complex patterns from simple starting points. Just think about it. With just a simple shape and the power of iteration and recursion, we can create an endless variety of unique and intricate patterns, each more mesmerizing than the last. Isn't mathematics simply amazing? But what's even more fascinating is that these complex patterns aren't just confined to the realm of mathematics. They're all around us, in art, in nature, even in the very fabric of our universe, waiting to be discovered. Despite their complexity, these mathematical principles result in some truly breathtaking patterns. But don't just take my word for it. Stay tuned as we explore some of the most famous fractal patterns and their occurrences in the world around us. Some fractal patterns have made quite a name for themselves in the world of mathematics. Take, for instance, the iconic Mandelbrot set. Named after the mathematician Mandelbrot, it is a stunning display of infinitely repeating shapes, each one a mirror image of the whole. The beauty of this set lies in its complexity, as it creates an intricate tapestry of spirals and curlicues, all derived from a simple mathematical equation. Another famous fractal pattern is the Julia set. It's similar to the Mandelbrot set, but with a twist. Each point in the Julia set is associated with a unique Mandelbrot set, creating a kaleidoscope of interlocking shapes and patterns, a testament to the infinite complexity of fractals. These patterns are not merely mathematical curiosities, they are also surprisingly common in the world around us, silently weaving their mathematical magic into the fabric of our everyday lives. From the spirals of a pine cone to the branching of tree limbs, fractals are everywhere, waiting to be discovered. Nature, it seems, has a penchant for fractals. It's as if the universe had a paintbrush, and with every stroke, it painted intricate fractal patterns. These mathematical wonders are not just confined to the realm of complex equations. They're all around us, woven into the very fabric of the world we inhabit. Take a fern leaf, for instance. If you observe closely, you'll notice that each leaflet is a smaller replica of the whole leaf. This self-similarity across scales is a hallmark of fractals. It's not just in its overall shape, but each segment, each vein in the leaf is a scaled-down version of the whole. How fascinating is it that such a complex mathematical concept can be found in something as ordinary as a fern leaf? Then there's the humble snowflake, a marvel of nature's fractal artistry. Every snowflake is a unique masterpiece, yet all snowflakes share a common fractal geometry. From the center, arms reach out in hexagonal symmetry, and each arm branches into smaller arms, repeating the pattern over and over, creating a stunning fractal structure. And what about coastlines? You might be wondering, how can something as irregular and seemingly random as a coastline be a fractal? Well, coastlines exhibit a property called fractal dimension. It's a measure of their complexity. The more jagged and intricate the coastline, the higher its fractal dimension. This means that the more closely you look, the longer the coastline appears. This paradox, known as the coastline paradox, is a direct consequence of their fractal nature. The beauty of fractals lies in their infinite complexity. They remind us that even in the chaos of nature, there is a hidden order, a pattern that repeats itself on different scales, creating a symphony of geometric harmony. So the next time you're out in nature, keep an eye out for these fractal patterns. Who knows, you might even start seeing the world a little differently. After all, fractals are nature's way of reminding us that beauty and complexity can coexist, and that there's always more than meets the eye. Artists, too, have found inspiration in the intricate beauty of fractals. From the delicate scrollwork of medieval manuscripts to the dizzying digital designs of today, fractals have found their way into the heart of artistic expression. This isn't surprising, given the infinite complexity and mesmerizing patterns these mathematical marvels exhibit. Traditional artists often unknowingly employed fractal principles, their intuition guiding them to replicate nature's fractal patterns onto canvas or stone. In the digital age, however, artists have the tools to deliberately explore and manipulate fractals, creating stunning works that blur the line between art and mathematics. Whether it's the spiraling brushstrokes in a Van Gogh painting or the mind-bending creations of digital artists like William Latham, fractals have enriched the world of art in countless ways. They've allowed artists to capture the infinite in the finite, the abstract in the concrete, the universal in the particular. Indeed, fractals have added a whole new dimension to the world of art. Now, you might be wondering, where can I find these mesmerizing patterns? Well, the truth is, fractals are everywhere. They're in the spiraling pattern of a pine cone, the branching of a tree, even in the cracks on a dried-up riverbed. The key is to look closely and let your imagination take over. You might be surprised by what you find, so start your fractal hunt today, and let the world of infinite complexity unfold before your eyes. Remember, fractals are all around us, if only we take the time to look. Fractals truly are a testament to the inherent beauty of mathematics. They are a mesmerizing fusion of art, math, and nature, reflected in the infinitely complex patterns of the Mandelbrot set and the intricate details of a fern leaf. These patterns inspire both artists and scientists alike, revealing themselves in unexpected places. So the next time you see a fractal pattern, take a moment to appreciate its mathematical elegance. Now it's your turn to join the fractal hunt. Dive into the magical world of patterns, explore around you, and see where you find these intricate formations. Share your fractal encounters in the comments. And remember, the world is full of fractals waiting to be discovered. Happy hunting! Fractals aren't just limited to nature and art, they've also found their way into the architectural world. Many structures we see around us exhibit fractal patterns, from the grandeur of towering skyscrapers to the intricate layouts of city streets. The repetitive patterns in buildings, the symmetry in their design, all echo the fractal nature of their creation. Take, for instance, the recursive patterns in the famous Gaudi's Sagrada Familia, or the spiraling design of the Guggenheim Museum in New York. These are just a few examples of how architects harness the power of fractals to create visually stunning and structurally efficient designs. These fractal patterns in architecture are not just visually pleasing, but they also offer practical benefits. They help in maximizing space, improving structural strength, and even enhancing acoustic properties. So, the next time you're admiring a building, try to look beyond its surface. Look for the fractals. You'll be surprised at how these seemingly complex structures are just simple patterns repeating over and over again. And remember, whether it's in the spiraling pattern of a shell, the branching of a tree, a piece of abstract art, or the design of a skyscraper, The beauty of fractals is everywhere. Fractals, it seems, are not just confined to the realms of nature, art, and architecture. They have also made a significant mark in the world of technology. In fact, they have become an essential tool in a myriad of technological applications. Let's start with computer graphics. Ever wonder how those incredibly detailed and realistic images in video games and movies are created? The secret lies in fractals. Computer graphics designers use fractal algorithms to create detailed textures, landscapes, and animations. These algorithms can generate infinite detail, allowing designers to create stunningly realistic graphics that can be zoomed in indefinitely without losing detail. Fractals also play a crucial role in signal processing and data compression. They help in reducing the size of digital files without significant loss of quality. This is possible because many real-world signals exhibit fractal properties, and fractal algorithms can exploit these properties to compress data effectively. Even in the field of electronics, fractals have found their place. They are used in the design of antennas and circuits. Fractal-shaped antennas can operate at multiple frequencies and are smaller in size compared to traditional antennas, making them ideal for compact devices like mobile phones. So, whether you're playing a video game, streaming a movie, or using your smartphone, you're likely benefiting from the magic of fractals. Indeed, fractals have become an integral part of our technological world, demonstrating once again that these beautiful, complex patterns are much more than just a fascinating mathematical concept. They are fundamental to our understanding and manipulation of the world around us. Did you know that the fascinating world of fractals extends even into music? Yes, that's right. There's a whole genre of music known as fractal music that employs fractal algorithms to create complex and intricate sound patterns. Just like in graphics design, these algorithms generate infinite detail, leading to music that is rich in texture and depth. Fractal music can be both algorithmically generated and composed by humans. When algorithmically generated, a computer program uses a fractal algorithm to create a unique piece of music. Each note, rhythm, and melody is determined by the fractal, resulting in a composition that is as unpredictable and complex as a fractal pattern. On the human side, composers use the principles of fractals to structure their compositions, creating music that is self-similar at different scales. This means that a small part of the music can resemble the whole piece, just like a small part of a fractal can resemble the entire pattern. Fractal music explores the boundary between order and chaos, much like fractal patterns themselves. It's a fascinating blend of science and art, demonstrating once again the pervasive nature of fractals in our world. So the next time you listen to music, try to find the fractals. Whether it's in the rhythm, melody, or structure, you might just discover that your favorite song is a beautiful fractal pattern waiting to be explored. Our journey into the world of fractals doesn't stop here on Earth. In fact, it goes far beyond, deep into the cosmos. Fractals are not just confined to our planet, they can also be found in the vast expanse of the universe. The distribution of galaxies, for instance, isn't random. They exhibit fractal patterns, clustering together in a way that's self-similar across different scales. This means that a small part of the universe can resemble the whole, much like a tiny part of a fractal can mirror the entire pattern. Even the formation of stars and galaxies can be seen through the lens of fractals. The intricate, branching patterns of stellar nurseries and the spiraling arms of galaxies are all examples of fractals in action. The universe itself, with its infinite complexity, can be seen as a giant fractal, with patterns repeating themselves at different scales, from the smallest subatomic particles to the largest cosmic structures. So the next time you gaze at the night sky, remember the fractals. Those twinkling stars, distant galaxies, and the vast cosmic web are all part of the infinite, complex, and beautiful fractal pattern that is our universe. The fractals are out there, waiting to be explored, understood, and appreciated. Fractals have come a long way, but their journey is far from over. As we've seen, these infinitely complex patterns are everywhere, from the shapes of trees and mountains on Earth to the distribution of galaxies in the universe. They've inspired countless works of art and have even found their way into our music and architecture. But this is just the beginning. Fractals continue to inspire new research in mathematics, science, and art. As we uncover more about these mesmerizing patterns, we're finding new and exciting ways to use them. For example, scientists are using fractal geometry to model data in fields as diverse as meteorology, finance, and even medicine. In the world of art, fractals are pushing the boundaries of digital design, creating visuals that are as captivating as they are complex. And in technology, fractals are playing a key role in the development of advanced algorithms and data compression techniques. As our understanding of fractals grows, so too does their potential. Who knows what the future holds? Maybe we'll see fractals used to model the human brain or to unlock the mysteries of quantum physics. Or perhaps they'll inspire new forms of art and music that we can't even imagine yet. The future of fractals is as infinite as the patterns they represent. So as we continue to explore this fascinating world, remember, fractals aren't just shapes or patterns. They're a way of seeing the world, a way of understanding the complex, interconnected nature of everything around us. And that's something truly remarkable.